Are you tired of being on the outside looking in, wishing that you were with all your friends inside of their quantity? Well, I have the solution for you. I present to you the distributive property. Here you can see that's you on the outside, and that's your friends on the inside. You're outside looking in. There's an easy way we can fix that. We can distribute you to each one of your friends. So there's you with your friend, plus you with your other friend. And it's the same thing, and you're all having a great time. The distributive property, for those that don't want to be alone anymore. Before we talk about using the distributive property in equations and using it to solve equations, we need to look at what the distributive property even is. So over here, I have it written out in a variable form, in a very generic form. I have A times the quantity B plus C equals AB plus AC. Well, what does that mean? So notice we have the A term on the outside of that quantity. Well, that means that it's multiplied by that entire quantity. So, through the distributive property, we can do this. We can say that each term in that quantity is multiplied by that outside term. So, we took A and we multiplied it by B, or B and multiplied it by A, kept our plus sign, and then we did C multiplied by A. And that's what the distributive property is. It says whatever term is on the outside of that quantity, we can take it and multiply it by each of the terms in that equation, or in that expression that we're working with. So now that we have that, let's look and see what we can do with that property in terms of solving equations. So let's look at this first example. We have 3 times the quantity x minus 2 equals 21. Now, because this 3 is on the outside, it's multiplied by this entire quantity here, this whole x plus 2. And since it's set up the way it is, I can distribute. So if I was going to show it, I'd do something like that. Just draw my arrows. Now I'm going to multiply the 3 by each term. When I do that, I get 3 times x, so 3x. Then I get minus, keep our signs, get 3 times minus 2, which would be minus 6, and that still equals 21. Now, I have a two-step equation again. So I will treat it the same way. I'm going to add 6 to both sides since I have a minus 6. So when I do that, these cancel. I get 3x equals 21 plus 6 would be 27. Now I have one more step, which is divide by 3. So my final answer would be x equals 27 divided by 3, which is 9. So let's recap what we did. All we did was we distributed this 3 throughout this x minus 2. We did that. We multiplied each term by 3, kept our sign since it was a positive 3, and then we solved it like a two-step equation. Add 6, divide by 3, and we ended up with x equals 9. Now, I want you guys to try this. So take a look at 5 times the quantity, 3 plus x, all equals 45. Take a second, pause the video, work this out, come back. When I look at this equation, 5 times the quantity, 3 plus x, all equals 45, I see that my 5 is multiplied by this entire quantity. So, I'm going to distribute this 5 throughout what's inside the parentheses. So I draw my arrows just for a good show. You don't have to do that. I just think it's good to show you guys what's going on. So we have 5 times 3, which would be 15, and then 5 times x, still positive, both positive, so we keep our positive. 5 times x would be 5x equals 45. Now, this looks a little different than the last one we did. Well, they're both positive, so you can just switch it around if you really want to. And it's the same equation. Now I have a two-step equation, so I might as well treat it as that. So I'm going to subtract 15 on both sides because I have a positive 15 here. These will go away. I have 5x equals 45 minus 15, which would be 30. Now I have one step left, and that's to divide by 5 because I want to get that x by itself. When I divide by 5, those cancel. X would equal 6. Now, let's look at something that's a little more involved. Something that takes and puts together all the steps that we had before. So I have the equation 2x minus 3 times 2x minus 3 plus 4 equals 33. There's a lot going on there. So let's take this apart, break it down, and work it out. First thing that I want to do is distribute that negative 3. Notice I said negative 3 because it's got a minus in front of it, and we're going to treat it like that. It keeps our signs in order, and it makes it a little easier to work with. So if I distribute this negative 3 into this quantity, I get something that looks like this. This 2x is going to drop down. Negative 3 times 2x would give us negative 6x. Negative 3 times negative 3 would get us a positive 9. Then we just keep the rest the same. Well, if you remember from yesterday, we can collect these terms together and make one thing. So if I collect my x terms, I have 2x minus 6x. Well, let's put that together. 2 minus 6 would be a negative 4, and then we keep our variable. Next we have 9 and 4. So 9 plus 4 would be equal to 13. And then we keep our equals 33 from before. Now, again, we're back to a two-step equation. So all I'm going to do is treat it the same way. I have a positive 13 here, so I subtract 13 on both sides. That'll cancel, end up with negative 4x equals 33 minus 13, which would be 20. Now all I have left to do is divide out this negative 4 to get x by itself. So that'll cancel. Divided by negative 4. I get x equals 20 divided by negative 4, which would be negative 5. Now, let's take a look back. Let's see what we did for a second, because you guys are going to do one in a second. I had this big, long equation here, and I saw, hey, I can distribute this negative 3 into this quantity to make my life a little easier. So when I do that, I drop down my 2x. I get negative 6x plus 9 plus 4 equals 33 still. Then I was like, hey, I have x terms and I have regular numbers. I can combine those together. And I combined my x terms and I got negative 4x plus 13 when I combined my regular numbers together, and that still equals 33. Well, now I have a two-step equation. So let's treat it that same way. I subtracted 13 from both sides because I have that plus 13. Then I was left with negative 4x equals 20 divided by negative 4 to get x by itself. And I got x equals negative 5. So let's take a second, and why don't you guys work on this one. 3 times 4x plus 6 minus 9x equals negative 3. Take a second, pause the video, work it out. I'll be back in a second. I have the equation here, 3 times the quantity 4x plus 6, all minus 9x equals negative 3. First thing I notice again, I can distribute this 3 because it's right outside the parentheses. So I distribute, draw my arrows just for good measure. When I distribute, 3 times 4x would be equal to 3 times 4, which is 12, and then we maintain our variable. Next we have a positive 3 times a positive 6. Well, positive 3 times positive 6 gets us 18. And then we leave the rest alone. Now I have terms that I can collect and combine. I have a 12x and a negative 9x. So I can think about it this way. We kept the same signs, we just switched the terms around. Now I can see a lot easier that we can subtract 12x and 9x. When I do this, 12 minus 9 gets us 3, and then we keep our variable and leave the rest as it were. Now we have a two-step equation again. Let's treat it like it is. So I have a positive 18, going to subtract 18 on both sides. That gets us 3x equals negative 3 minus 18, which would be negative 21. You can think about that like adding, because you have a negative number and you're taking more away from it. So it's like you're adding, just with the opposite sign. Now, if I want to get that x by itself, I'm going to divide by 3, because I want that 3 to cancel out. When I do that, and I'm going to move it over here for a second, when I do that, I'm left with x equals negative 21 divided by 3 would give us negative 7. Now that we've gone through a couple of examples, let's talk about what we actually did today, what we really accomplished. Today, we learned about the distributive property and how we can use that in order to help us solve equations. By doing that, we took the term that was outside of the parentheses and we distributed it throughout the terms that were in the parentheses. This got rid of the parentheses and allowed us to combine like terms in order to break the equation down into a simple two-step equation. Once we did that, we solved it just like any other two-step equation. We added or subtracted, then multiplied or divided. And that got us, what that variable was. We isolated that variable and found out what it equals. Eagle-eyed students will notice that each one of these videos, each day that we're working on stuff, we're adding one more step to solving equations. So eventually, later on down the line, you're going to have these mile-long equations that take 3 years to do, but they might not take 3 years and they look super hard because you understand what's going on. You understand how to take them apart and how to break them down and how to make it easier to look at, easier to work with. So tomorrow we're going to add our last step. We're going to start talking about having variables on each side of the equal sign. And that's going to become important later on down the line when you start solving those mile-long equations that I started talking about before. Anyways, that's it for today. You've been the students. I've been the teacher. Come back tomorrow when we start learning about having variables on each side of the equation. I'll see you guys tomorrow.